Hello, and welcome to the lunchtime webinar series for the Greenhouse Gas Removal Research Programme. My name is Phil Renforth. I'm the Science Coordinator for the research programme, and I'm delighted to introduce the speaker for the webinar, which is Dr. Vaughan from the University of East Anglia. Nem is a Senior Lecturer in Climate Change and works within the Tyndall Centre for Climate Change Research and is based in the School of Environmental Sciences at the university. Her research is all about how global societies can respond to a changing climate, and her work's been particularly influential in the greenhouse gas removal space. She's a PI for one of our consortium projects, which is around the feasibility of afforestation and biomass energy carbon capture and storage, or FAB-GGR. So we're delighted that she was able to come and give this webinar. There's a slight discontinuity between this recording, which which I've recorded after the webinar, and the webinar itself, because we forgot to record the first part. So I hope that's not too jarring, but I hope you also enjoy the webinar. Thanks.
So what I want to talk about today is I'm going to tell you a bit about the project and the kind of approach we've taken, who's involved. There's a huge diversity of kind of elements to the project, and particularly diversity to disciplines. But I'm actually then going to just hone in and tell you about two papers, one that's published and one that's currently under review, because trying to cover everything, I won't be able to get into any detail. So I've gone for one stream of the work. And then I'm just going to the last section is not as big as I thought it might be, because I ran out of time talking about all the other stuff. So just a little bit of a quick wrap up at the end. So first of all, then, first 10 minutes or so, 10, 12 minutes, I want to tell you about the project. And the crux of our project is to examine the real world feasibility and consequences of large scale afforestation and BECCS. So the project involves this lovely group of human beings from the University of East Anglia, University of Exeter, Manchester, Aberdeen, and then one of our Manchester colleagues moved to Aston in Birmingham during the course of the project, and so also Miriam and Alberto. We are within the GGR program. We are the most interdisciplinary of the project. So this is NERC funded as a program, but we are very interdisciplinary. So we have Anna and Emma and Tim down at Exeter thinking about Earth system models, Ashley and Anita in Aberdeen doing very process-based crop modelling, so quite familiar NERC territory. And then we have Miriam, Alberta, Samira working on the LCA analysis, so starting to step towards the engineering there. Brett Day comes from the economics side of things, looking at economics and policy. And then there's quite a big group of people who are involved in much more card-carrying social science, so ranging from environmental psychology to political science and kind of sociology and society and energy transitions. So sorry if you've signed up for a heavily NERC session right now, but I'm actually going to pick a piece of work that's quite social science. So buckle in, enjoy. It's only 40 minutes. You'll cope, I'm sure. Hopefully you'll find it interesting. So yeah, big group of people, very interdisciplinary. And I think personally, I found it an utter pleasure and a joy to spend the last 4 years working with this group of people to do the scale of interdisciplinary work we've done on this project. You know, going from some really different worldviews and some really different ways of thinking about things, you have to, on one hand, be very prepared to be very open and clear about your methods, your approaches, and your assumptions. And on the other hand, you have to be prepared to actively listen to the other party as well. So we've had some very different points of view within our project meetings, but it's always done really respectfully and really interestingly. So I have personally enjoyed it a lot. So the work of Johanna Forster and Diarmaid Cleary are the lead authors on the papers that I'm going to talk to you in the second part of my seminar today. All right then, so I wasn't completely sure about the level of background on the topic. So the basics then, FAB-GGR is looking at afforestation and BECCS. Afforestation, large-scale tree planting. I'm going to try very hard not to go off on a tangent about how that term works at certain levels and certain remits and doesn't work when you get to real world kind of applications. Afforestation isn't a very meaningful term out in broader society. It means a lot to international and national climate policy, and it means a lot to Earth system modelers, and it means a lot to integrated assessment modelers. But take it to the kind of boots on the ground, and it doesn't really doesn't translate as a term at that level. It's more about planting trees or woodlands or timber industry, a range of other things. So it's actually quite complex when you take it out to the real world, and that is going to be a bit of a recurrent theme of my talk to you this lunchtime. So the biomass energy carbon capture and storage, I'm going to assume the majority know what this is, but for anybody who doesn't, let's go with the basics here. It is a proposed technology where there's one example in the world at the moment today. And the crux of the idea is to, can't sure if you can see my mouse or not. I'm going to assume you can see my mouse. But the crux of the idea is to, in the process of growing biomass, you're taking CO2 out of the atmosphere. And then over on the right-hand side here, you use some kind of energy conversion process, for example, here, generating electricity. And rather than letting the majority of that CO2 escape to the atmosphere again, you are capturing it and compressing it and storing it underground. However, there's a bit more to that story. For example, there are a series of process-based emissions from when you grow that biomass to harvesting it and processing it, drying it, palletizing it, maybe baling it, depending on the type of biomass, transporting it by truck within the UK, for example, or by ship if you're going between countries. And then so there's some emissions here at this middle section, but also the one at the front end of the process, which can cause some functionally stops a BECCS system being GGR or not, like delivering negative emissions or not, is emissions from land use change. So what was the land that you've grown that biomass on used for previously? So that's my cut down tree question mark. Is it a small arrow? Is it a big arrow? Okay, so that's the simple version of a BECCS system. Grow some biomass, use an energy conversion process, capture and store the CO2. Make sure you consider what the emissions are in between and consider the land use change that's been involved to get to the growth of that biomass. Now, those of you who are interested in some of the more nitty-gritty bits of this then, again, real world complexity on this stuff, although the simple version of what biomass energy with carbon capture and storage is this kind of grow some dedicated energy crop, make some electricity, post-combustion, capture and store the CO2. You can actually have a range of different sources of the biomass feedstock. So it could be a dedicated energy crop. So the work that Astley and Anita did and the work that Emma and Anna did both focused on miscanthus, so a dedicated energy crop. And that's the image on the top right is some miscanthus being harvested in the UK. But you could also have short rotation coppice. So one of our supply chains looks at short rotation coppice, so willow or poplar. This image in the middle is some poplar being harvested. You can also have residues though from either agriculture, such as straw from wheat production, or forestry residues. So the bottom picture is some pellets of forestry residues from the paper and pulp industry in the southern states of the US, which is pelletized there and then shipped to the UK and burnt in the Drax power plant in Yorkshire. So there are a range of different biomasses, and each of them have a different impact on land availability. They have a different water demand, nutrient demand. You'll get different yields growing them at different parts of the world. And so it gets quite complicated in terms of some of the real world kind of impacts and consequences, depending on which biomass you're using for your BECCS system. The second step is energy conversion, where as well as electricity generation, you can have a BECCS system that involves liquid transport fuels. And we've also got one of our supply chains looking at hydrogen. And you actually see all three of these energy conversion processes used in the future emission scenarios. Integrated assessment models are using different combinations of them. Again, there you will then get different kind of conversion efficiencies in terms of the carbon removed for the power output. You also need to think about, what system you're tapping into. And then the final step that's common to all of them to make it a BECCS and a GGR system is the CCS part, the carbon capture and storage. So this involves, in each case, capturing the CO2 pre-combustion or post-combustion, depending on your system, compressing it and dehydrating it. So those three steps, captured, compression and dehydration, all have an energy penalty. So that's something to factor in. And then you need to be storing it in either depleted oil and gas wells or saline aquifers, which can currently occur in the same sedimentary basins. For example, in the North Sea, we've been injecting, Norway at least, Sleipner has been injecting CO2 into saline aquifer there since 1996. So there is also another type that maybe the DAX lot will have talked to you about is mineral carbonation, injecting into basalts, which if you go on YouTube, that's the kind of Climworks Reykjavik site where they're using the geothermal power, doing some direct air capture and storing it. But that's another option. So interestingly, the geology and therefore the geography plays out on the CCS there around what your suitable storage sites are. Using the CCS, capturing it and using it is not GGR because the utilization route ways release it back to the atmosphere. Okay, so that's our basics about afforestation and BECCS. Why did we as a project focus on these two? Because they're in all the future low emission scenarios. In 2016, when we wrote the bid, project started 2017. Afforestation and BECCS were the main players in integrated assessment models. So the integrated assessment models construct the future scenario, future emission scenarios, and in the low emission scenarios, you actually find that in the 1.9 watts per square meter, 2.6 and 3.4 watts per square meter emission scenarios are all having some amount of GGR, and almost all of those are using afforestation or BECCS. So the figure here we have is from the special report on 1.5 degrees C. This is just from the summary for policymakers. And you can see here 4 different possible scenarios. In each of them, the pale grey shows you the emissions from fossil fuel and industry. The thick kind of teal, let's say, line showing you the net result of all of this action. In the pale brown is agriculture, forestry, and other land use. So you can see in all of them, it starts with positive emissions, so continued deforestation. That goes down to 0 by about 2030, and then except in the final scenario on the right. And then you have in each of them the amount of afforestation, kind of topping out around 3 to 5, maybe 3 gigatons of CO2 per year removed. And so that in itself tells you something about the difference between the afforestation and BECCS. By the way, the BECCS has a much bigger potential capacity. The BECCS is then in yellow. So the biomass energy carbon capture and storage is in yellow in each of these scenarios. So you can see there is different amounts that may be used, and that's intricately connected to how much emissions reduction, how much decarbonisation you manage on the other side of that balance sheet. The other reason that they're really good to look at together is that they both compete for the same land requirement, or they both have a land requirement, land availability, land suitability issue and component to them. And not only do they compete with each other, they also compete with food provision as well as other ecosystem services such as biodiversity. So land availability is a kind of core issue in the two of them together, which is why we found they were useful to look at and consider in our project together. So just a few things to note, give me a second. So one of the things that's hard about BECCS, one of the things where the kind of complexity and the uncertainty comes in, is it's quite a novel technology. There's actually only one BECCS system active today in the world, and that's in Decatur in Illinois. And on the right-hand shot, you've got an aerial shot of that. And the currently active part of this site, at the very bottom, again, I don't know if you can see my mouse or not, but at the very bottom is a corn ethanol fermentation plant that is making a liquid transport fuel. So it's going to be burnt in cars and trucks, for example. And then the IBDP bit was an initial, it's all supported and funded with federal money for the Department of Energy. So it's a demonstration project. They were looking at a demonstration project of injecting CO2 from the fermentation stage of making the bioethanol, because this site in Decatur is sat on top of the Mount Simon sandstone complex that has a saline aquifer in it, so that's what it's injecting into. And these are all the little dots, are all the test sites. They were checking the site security. And in the second phase, it's the purple line that goes up north to south on this image, going up into the second part, the Illinois Industrial Carbon Capture and Storage project. So these guys, I think it's like 1 megaton of CO2 per year is being injected now in this phase of it. So you're only working project is a demonstration project. It's not like market ready in that sense. So it has additional funding as a demonstration project. It is a liquid transport fuel, so you're getting less of a fraction of that biomass actually stored, because obviously a significant proportion is going into the transport fuel, which is then combusted and released back to the atmosphere. So other factors in terms of kind of where we're at, and that's technology readiness level, is that BECCS that are not BECCS but are relevant is Drax in Yorkshire, which is a large-scale electricity generation from forestry residues. And also globally, we have about 18 greater than 0.5 megaton CO2 per year CCS facilities. Now, most of those are natural gas processing, and most of them are enhanced oil recovery, so they're not delivering any emissions reductions, but you have got the skills and the expertise there. So just as a general point around BECCS is that if I went back a slide to the far left example where there is no BECCS in that scenario, you'd still have a significant proportion of bioenergy happening in order to decarbonize the energy system. And there'd probably also be some CCS happening because it's quite valuable to decarbonize industry, particularly heavy industry. And so BECCS is not the only place where you're going to have large-scale bioenergy and CCS. So both of the components of BECCS are used to decarbonize different parts of the energy system, even if you have an absence of GGR. If your GGR was only afforestation, you'll definitely have a load of bioenergy and you'll probably still have a chunk of CCS happening anyway. So that's just an important caveat to remember. So then what do we do within the project? The main aim of the project, as I said earlier, was to examine the real world feasibility and consequences of large scale afforestation and BECCS. And I think a big driver, particularly early on, was to functionally was to examine the assumptions that are used within integrated assessment models. Because what was happening was figures like the 1.5 that I showed you showing this massive amount of afforestation and BECCS, and the question's kind of like, is that feasible? I mean, that's the crux of almost like the whole program. Is that feasible? And so, so part of that has been exploring the assumptions used within them. So there's lots of strands, as I kind of got into before, in terms of the different disciplinary angles. There's lots of strands to the work. The expert elicitation I'm going to tell you about today. Colleagues looking at the societal and political aspects using literature review, using digital methods, and also using interviews as methods there. Miriam Broder and colleagues are doing the life cycle analysis and the process engineering to look at the life cycle analysis of the different supply chains, and then colleagues looking at some global modeling and crop process modeling to look at the kind of trade-off around yields and carbon cycle and climate, as well as the kind of economics and policy element. So just a couple of key points then about our whole project's approach and assumptions. We used consistently RCP 2.6 SSP2 as a kind of consistent emission scenario. So importantly there, it does assume strong mitigation action and has less climate impacts within it. There's a strong UK focus to the project, but it does have these global modelling elements to it. And I think a key architecture to the way we approach FabGGR was the use of 4 supply chains that are detailed here. So we have one using forestry residue. The top one is very Drax-esque. It's using forestry residues for electricity generation and post-combustion CO2. Then we've got growing miscanthus is the second one with UK-based smaller CHP plants, and then doing short rotation coppice, but using gasification, pre-combustion capture, and hydrogen production. And then we have an afforestation where we take unforested land and forest it within the UK. So these scenarios we'll come back to in the second part of the work on the expert elicitation. So I have managed to get where I wanted to get to, just about, but you'll understand that I speak a bit quickly. So I apologise profusely for going too quick and trying to cram too much useful information in. The work I'm going to tell you about here is Forster et al., published in Global Environmental Change in 2020, and Diarmuid Cleary's paper, which has gone into Global Environmental Change in December, and they've had one review and waiting on a second reviewer. But it's also with my colleagues Claire Goff, Irene Lorenzoni, and Jason Chilvers. So this is a team effort. Tell you about what we did on this strand of work. So the 2 papers are around 2 separate one-day workshops that were both held in London. One was in July 2017, the other November 2019. In the first, it was 19, in the second, it was 22 participants, so around 20 people came along, the majority of whom were from the UK. And what's very cool is about 50% of the people who took part in the first one were able to return either directly themselves or with a close colleague swapping out for them. So there was a nice element of continuity, which is quite interesting to capture. This is a really fast moving area in terms of the academic work, but particularly in terms of the policy and in terms of the kind of innovation and the kind of business interest in this as well. So that's why it's valuable to have had these 2 snapshots, if you like, but to have this continuity across it. About 50% of the participants were from business and industry, ranging from really large scale national and international multinational companies down to really small, very targeted SME type companies. Quarter were from NGOs, and that's not just environmental NGOs. We had, for example, Oxfam there. We tried to broaden that out to not just climate change NGOs, or not just environment ones. And then 25% were policymakers, mostly UK, but also some who've got more of an international, based in the UK, but with more of an international remit. And then within that group as well, the expertise, BECCS doesn't exist today, really, as a thing. And so what we had to do instead was draw on people with expertise from the bioenergy and forestry sectors, draw on people with expertise in carbon capture and storage and associated, and then draw on people who've just got a broader climate change expertise. So who's missing from here? Academics are. I think we had one to the first session who went got sorted under business and industry actually, but not academics here, because in academia we've got conferences, we've got papers. We were interested in going beyond academia to what's happening in the real world, on the ground, and the different drivers that are moving afforestation and the BECCS potentially forward in the UK and globally. We also wanted a diverse set of voices. We were not trying to reach a consensus. We were not trying to find an answer. We were interested in the breadth of opinions and in, hearing a range of voices and perspectives on this, and voices that challenged one another. And so, yeah, that's the logic behind the type of people that we invited for the day. Methodologically, okay, so what do we do? I'm sitting here telling you about some social science. What do you guys actually do? So we had a big research team actually there to support this. So it's functionally, it was facilitated discussion. So we had some work in plenary, some work in breakout groups that were down to 4 people, but each of those groups were facilitated by myself or Irene or Jason or Claire, for example, or Johanna. Johanna and I swapped out for 2 of them. So that you can make sure you're hearing the different voices, that people get time to speak, and that people have different ways of communicating their responses to the questions you pose. Again, we were not seeking consensus, and as with any of these things, if you've ever participated in one, there's a lot of post-it notes. So the 2 main questions, there was a 3rd session that I'm not going to cover that we did during the one day. So the 2 sessions I am going to talk to you about are what were the key issues relating to using large-scale afforestation and BECCS to remove greenhouse gases from the atmosphere. And then at the end of the day, this first session was done in smaller breakout groups, and then we fed back, then we did the middle activity, and then at the end of the day in plenary we did what criteria should you use to judge the feasibility of large-scale afforestation and BECCS for GGR. So obviously the 2 are kind of getting at the same thing, and you'll see that in the results that some of the same things come up, but also people have been on a journey through the day. They've been party to discussions formally but informally over coffee and lunch, and so you'll also see, but also when it comes to feasibility, it does change the order of importance over some of the results, which is, I think, very interesting. All right, so what do we do with all the post-it notes? We digitize them, we code them, so we organize them and group them. Now that's obviously can be quite a subjective process. So this was done in iterations, at least 3 iterations, involving initially the lead author of the paper, but then also with a second group, and then we all went through it again a 3rd time. So it was gone through multiple times, and so it was a very collective effort in terms of the analysis, which helps to iron out subjectivity, which helps to it doesn't take it out at all. It's still there, but it helps to challenge that and try and be very aware of that subjectivity. So in response to these key issues question, then these are, I think we got over 280 coded responses. So on average, each participant made about 13 different coded responses. The little gray numbers are just the count on, it's just simply a count on the number of those responses. And then we have sorted them out in the actual paper. The link's there if you're interested on the bottom of the slide. You have these kind of main 12 themes, and within that we have sub-themes. Okay, but of the main 12 themes, that's what you're seeing the titles of here. So you've had to take someone's nuanced point and group them together with similar points, and then end up here. So I'd argue, let's have a little look at these then. I'd argue that 6 of these are not surprising in the slightest, that most of the people on this seminar today would probably sit down thinking, all right, BECCS afforestation, and would write down, well, this is probably an issue, this is probably an issue. So we've had first of all our 3 standard pillars of sustainability. So you'll see, again, I'm not sure if you can see the arrow, but we've got top right, we've got environments, this is getting in the way, top right, we've got environments, and then also in the middle, economics, incentives, and bottom left, social implications. So those 3 are standard pillars of sustainability. And given that we're talking about 2 large-scale technologies that are going to come about because of climate policy and are going to have a big land component, and that particularly around the BECCS, there's a lot of it's an early, it's a technology that doesn't fully exist at market level at the moment. There are these technical questions, these governance questions, and these land use questions. So I think these 3 headings, along with the standard 1, 2, 3 here, are fairly, oh, I didn't mean to do that, are fairly, my mouse is being a pain, are fairly what you might anticipate. Okay, there we go. So this this technical questions about this developing, an emerging technology, land use questions because they all have some land availability requirement, and governance because it's climate policy that's going to deliver it. All right. So the ones I think are interesting are these three here. So spatial scale, temporal scale, and greenhouse gas accounting. So these are kind of the headline issues. They had some sub-themes underneath them. But I think that when it comes to, I think this really does get to the heart of some of the continual tensions that happen around issues to do with large-scale afforestation and BECCS to deliver GGR. The large scale is important. Very small scale forestry, isn't going to be a problem, but the scale at which you're talking about for the afforestation, the scale of biomass production needed for BECCS, for example, and when we go back earlier to our scenarios, the amount of the yellow on each of those scenarios, up to 20 gigatons of CO2 removed per year on the furthest, most extreme example of that scenario. That scale of it. So spatially, but is a big issue, but also the temporal scale and the greenhouse gas accounting becomes a kind of perpetual issue around what I think is about the challenge of the terrestrial carbon cycle versus how economics and policy works. Okay, so what time frame are you interested? What level of permanence? Where's your boundary conditions on starting that LCA? Right? Because a tree doesn't take carbon up because you planted it today. It takes carbon up over time. And yet from a kind of policy and economics point of view, you want much more of a snapshot approach, right? And that temporal scale relates to the greenhouse gas accounting, but also the temporal scale relates to this rapid rollout, for example. And so I think there is an inherent challenge with the spatial and temporal scale of the terrestrial carbon cycle versus trying to turn this into something that delivers I realize where I've lost that piece of my screen to now. Okay, that delivers like emissions per year, CO2 per year removed, for example. Now, the final group that I think is interesting is our last three, which is justice and ethics, competing human needs, and real world complexity. And I conclude my seminar today on the headline real world complexity. So it's part of where this comes from. So the justice and ethics maps really neatly actually to Duncan's talk next week. But this issue around fairness and this issue of who's bearing the burdens of, for example, where you're growing the biomass versus where the CCS is, but also the mitigation deterrent issue of having options of our four scenarios like the furthest right that allows you to decarbonize later, act slower on decarbonisation, and the impacts of that then in terms of some of the negative side effects of very large scale bioenergy. And so this is the term that Duncan and his colleague Niels Markussen use, mitigation deterrence rather than moral hazard. And so that actually came quite high in terms of mentions, with 17 mentions. Competing human needs down here comes up again a bit more in the next stage, but this idea of the competition for land use and bioenergy around food security or communities and livelihoods, and then real world complexity. So just the complexity, the heterogeneity and the diversity that happen when you try to take these ideas, these approaches to GGR out into the real world, and then how kind of messy and complicated it gets. In terms of making it happen, in terms of the amount of carbon you actually are going to remove, for example. So we are able to track all of the comments that everybody made and have a look at who mentioned what. So our 12 little squares from the previous slide are now listed here, ranked by overall number of mentions. So environmental issues were quite high, technical, governance, land use. And then down here, the real world complexity and diversity is down here, competing human needs. And then our 19 participants, self-stated dominant expertise between bioenergy, forestry, CCS, climate change. Same participants again, but sorted by their different sectors. And you can see where stuff's coming. So policy people tend to have a very well-rounded view. Business and industry are a lot less interested in competing human needs, in social implications, justice and ethics, real-world complexity. Much more interested, interestingly, around governance, economic incentives, the technical questions. CCS, again, less interested in this side, also less interested obviously in the land use side, because we'll tend to have more focus on the technical issues and the economic incentives issues, and the greenhouse gas accounting actually was very high in this group. So just to show you in the paper, we unpack in a little bit more detail this. So the second question of this session was about feasibility. I realize I'm talking for a bit longer than I meant to. So just to skim over this then, that a lot of these ones echoed actually what we got in the issues session, but the ones that, again, these are sorted as I presented them here by mentions in the top right. Okay, so infrastructure and technical were the most commonly mentioned feasibility criteria, but the second most commonly mentioned one was the sustainable production and supply of biomass. Carbon markets and actually fit for purpose carbon markets, like, are they going to work? Are they going to work well to ensure this component, for example? And what was very interesting was that co-benefits and multiple objectives kind of, which in some ways was coming up under competing human needs in the previous one, jumped very high in this element. So when it comes to how would you judge the feasibility of these supply chains, co-benefits and meeting other objectives beyond just carbon removed became much more important as seen as a way of achieving them. So again, that was broken down. I'm going to skip over that bit. So the key points in this paper are then that the biophysical and techno-economic aspects of the feasibility of BECCS and afforestation for GGR are important, but also important and often overlooked to some of the social and political aspects. So questions around governance were very high and recurring in this. Justice and ethics, is it fair? It's the mitigation deterrent issues, the societal implications, these computing human needs, and this idea of real world complexity and the co-benefits and multiple objectives. So that stuff isn't captured when you look at those scenarios that are presented originally. The scenarios tend to capture biophysical and techno-economic fairly well, but they don't tend to capture, in the integrated assessment models, don't tend to capture all these elements, which were also important in terms of our stakeholders' perspective on judging the feasibility of delivering afforestation and BECCS. And so that's a key kind of point, and some more analysis we did within the paper was directly comparing to what is and isn't represented in integrated assessment models. So what we did, go backwards. What we did then in the November workshop was we took the feasibility criteria from the first workshop, and we took a different method this time. So the method we used in the second workshop is called multi-criteria mapping. It involves conducting a 1.5 hour interview with each of the 22 participants in the 1 to 2 months before the workshop. So everybody's taken part in the interview. They then come to the workshop. So the feed in from the previous workshop is this yellow bit of our feasibility assessment. This was just used as a prompt. Not all the participants wanted to look at it. It was just available to them it was available to them, but it wasn't essential that they read it, and not all of them, by far not all of them read it. So only a few did, but it was there. And of course, a fraction of these people took part in the first workshop themselves anyway. So the interview is conducted, and during that interview, what happens with multi-criteria mapping is we took the 4 supply chains I mentioned, and I'll go into some more detail on the next slide, and you ask each of the participants in their interview to create a set of criteria to assess the feasibility of these supply chains. So they construct the criteria themselves, and then they are asked for each supply chain to give an pessimistic and an optimistic score against each of the criteria. Okay, so that is multi-criteria mapping, developed originally by Andy Sterling at Sussex and used by Rob Bellamy now at Manchester, Jason Chilvers and others before. This is the detail of the supply chains then. So they have different biomass productions, as I said, residues, miscanthus or short rotation coppice in the UK. The harvesting processes are different with different scales, the processing, whether it's being pelletized or chipped or baled, the transport, these are within the UK, these two, so it's road only, and on the left is ship and road and rail. The type of energy conversion is large-scale electricity generation, so that's 4 gigawatts as opposed to combined heat and power at 100 megawatts of electricity, and the gasification unit to produce hydrogen is larger. It's in the kind of middle-sized at 500 megawatt unit. And then these two are post-combustion capture, and this one's pre-combustion. All the storage was assumed in the same to be in the North Sea, and this is the afforestation. The colour scheme is helpful for the next slide. So this is just an arbitrary scale, don't focus on that. And remember, we asked all 22 participants to give a pessimistic and an optimistic score, which is why you have a huge range on these things. But it gives you, it's intentionally a bit oblique. And in the paper, we go into more detail, breaking it down by groups and breaking it down by individuals. But this just aggregates everyone's scores together. So this is our power with residues supply chain, combined heat and power with miscanthus, hydrogen with short rotation coppice, and afforestation. And what you can see is that afforestation performs better than the others. Now, in the policy group, that wasn't true actually, but the whole participants all aggregated together. Afforestation outperforms the other 3. What we've done here is just highlight where the criteria against which they performed well, and then here on the left is the criteria that they performed poorly on. So for example, let's take a look at land availability and suitability. So for power with residues, using forestry residues, that scored well on the land availability and suitability criteria. But miscanthus, dedicated bioenergy crops, and afforestation both performed poorly around land availability and suitability. And so we can go into much more detail, but I've overrun, so I'm not going to just now. But just to say that this is how you then bring to get back together the scoring and the ranking that the participants did as part of the multi-criteria mapping. Obviously, the nuance is in what those criteria were. So a bit like our green blobs and then our yellow blobs we had earlier, these were the criteria everyone came up with. These are the counts of them. So 22 people involved came up with an awful lot of criteria, nearly 300. Two things to just point out is the italicized ones are ones that did not appear in the Forster work, which did appear when we went to this granular level of supply chains. And the dotted lines are where they were heavily interlinked. So land availability and suitability in the comments was heavily interlinked with social acceptability, farming practice, land use, and policy effectiveness. And so one I just want to highlight is, thanks Phil, 5 minutes, is the energy systems and industrial integration and location. And I think that was a key thing that came out of this going down to the supply chain rather than just talking in kind of broader terms in the first workshop. So there's lots of detail here that I don't have time to get into, but we get into it in the paper. So it's a bit of a forerunner. I'm going to skip over the next exercise because Phil's popped up on my screen to tell me I've got 4 minutes left. So what we did by taking a supply chain approach was enable us a much more granular detailed appraisal of this real world feasibility question. So rather than people just kind of having to think about the bigger picture, it causes it to become much more detailed and very specific, if you like. Overall, the afforestation was performing better, but there are some other key factors that got identified in the analysis of this paper. Farming communities, culture and skill sets was seen as quite a barrier in some cases or an enabler in others. Land tenure, land rights, land ownership also came up. And policy longevity was the key element there as well, about committing to these different shift in land use in communities. And this bit more skewed towards the UK. Global cooperation and sustainable biomass supply was a key theme, but also I think a key one for me that came out of this was about location. By going down to supply chain, location matters. What infrastructure do you need? Where is it? What's the climatology? What are you growing? Where? What output markets are you feeding into? So for afforestation, you're feeding into a timber market, you're feeding into a biomass energy market with your residues. If your combined heat and power is a very different location problem to a large scale electricity generation site like Drax, and then what communities is happening in. So in terms of taking it forward, this is the next bit of work I think is interesting looking at. This is about communities and place. So just to wrap up all together then, across the expert elicitation work, lots of detail and lots of nuance in the paper, but this issue we keep coming back to is around real world complexity. Trying to ask this question of, all right, integrated assessment models come up with these scenarios, they've got some nice big numbers, is this feasible? You start getting very stuck on questions like, okay, well, what biomass are you assuming? Where is it grown? And what was the land use prior to planting? Get the land use prior to planting wrong, your indirect and your direct land use change emissions don't cause you to not have GGR because you've emitted too much at the beginning. What biomass? Is it residues? Then you don't have a land availability issue. If it's all being delivered by dedicated energy crops, then you get into this question of where are you growing this biomass, and particularly if you're thinking about our scenarios, the ones on the further right, which had some insane amounts of BECCS going on. But also, what energy conversion process, where in the decarbonised energy system is this fitting? And that gives you a lot of nuance there in terms of your efficiencies, in terms of some of the energy penalty to the system that you've set up. So this question of use of residues, I find a lot of people's back of envelope work says BECCS doesn't work because you'd need a land area of X, when actually most of the integrated assessment models assume up to 50% is delivered through residues, i.e. no additional land use area required. But on the other side of that coin, you have this almost perpetual circular interdependency of, okay, what's your diet assumptions? What's your yield improvement assumptions? So your land availability is not something you can pin down easily. It's so interconnected with yield questions. Obviously, there's a climatology component to that, but also societal questions around diet, that and you're trapped in like a continual loop of I don't know how much land there is for these reasons. And I think crucially, to deliver GGR from BECCS, right, so permanent removal of carbon from the atmosphere, the crux of it is sustainable supply of biomass. So with that, you need associated really strong monitoring, reporting and verification, and strong environmental governance. Because without those things, you can be sticking loads of CO2 down a pipeline, feeling very smug about yourself. But if you've not sorted out the front end of that supply chain, if you've got poor sustainability in terms of your biomass supply chain, then you are not delivering to the climate system greenhouse gas removal. You're sticking CO2 underground, but you're not net removing it from the atmosphere. So we did other papers, we did loads of science into policy. Thanks ever so much for listening. I told you it would be fast. Done.
Thanks, Nem. That was fantastic. Really nice overview of the project and your work. I've popped the ability for you to unmute yourself, and the chat function is now on. So feel free to raise your hand or pop your video on and ask them a question.
Phil, do you want me to take my slides off? Would that help?
Yeah, why not? There
we go.
You can always put them back on if you need them. Do you have anyone who's wants to ask the first question? Elisa, please.
Can you hear me?
Yes, I can.
Thank you very much for the wonderful overview. It was really interesting, and I personally also had quite good experience with involving the supply chain, and so special compliments for involving so many actors. That was really interesting to see the insights. I, however, have a slight concern that you mix up a bit perceived performance and actual performance. So the performance that you were talking about is actually perceived performance, and it might be slightly different from what would actually happen in the reality. And I particularly have concerns regarding afforestation because it's scored so high. And for me personally, it is the alternative that I could imagine, well, best probably of all the alternatives. And I also would imagine that it's scored so high just because, yeah, it's easier for people to imagine how it works. And the others include a lot of technical issues. So how would you comment on that? Do you think that the actual performance would be very much different from this perceived performance?
Absolutely. No, I think you've nailed totally. Absolutely. So afforestation is something we know about, right? We know how to plant trees. We've known it. Go down the road and plant a tree, right? That's straightforward. Dial up Woodland Trust. They'll send you a hedge. You can go and plant it in your back garden tomorrow. Whereas BECCS has this, so on one hand, you've got this like technological innovation. So it's again, this difference between what might be anticipated, might be delivered. Now, I would argue that you have a bunch of insights with CCS people in the room. Like I said, there's about 18 large scale CCS plants already. So it's not completely, it's not as like far ahead. But there's always this issue with kind of engaging with stakeholders with upstream technologies that don't exist yet, right? So there's always a challenge, and it's absolutely something that we comment on not only in these papers, but in the work that is led by Jason and Laurie Waller, is this issue of the disparity between known technologies. So sometimes what happens, actually, when in Laurie's work looking at the literature about this, is that known technologies come up with more problems because we know what the problems are, right? And some people will tend to think of less problems with kind of novel and innovative and not quite fully formed technologies because they can only think of a couple of things. And other times, as you've said, Alicia, it can be the other way around. And so that is a big difference between the two, and particularly as you get to larger and larger scale as well, right? It's not just delivering a supply chain, it's scaling that supply chain up, you know, to that like 5 or 10 or 20 gigatons CO2 per year. And so trying to engage with what those are, what those kind of issues will be, and what that will look like at that large scale globally are also quite challenging to do. Whereas again, afforestation, we have more of experience of it. So it is something that we comment on in the paper, and it's a really good point.
Thank you.
Thanks, Elisa. If anyone else has any other questions, please raise your hand or pop your webcam on. Just a comment from Simon Howe from NERC. It's been very gracious in acknowledging the other funders as part of the program, which is also EPSRC, BECCS, but also ESRC, who are obviously interested in the social sciences stuff. Shinshiro, if I'm getting that correctly, please. Oh, there was a phantom hand, I think.
Hand up, hand down.
Yeah. Maybe while other people are thinking, I could ask a question then. I think, you know, when you started your presentation, you were talking about sort of the global figures for the potential of afforestation and BECCS. And I gather from your presentation that, you know, once you start putting some of the complexity, the real world complexity onto those systems, the potential probably decreases than what we're thinking at the moment. And I'm just wondering, I know you've sort of shied away from giving absolute figures, but do you think, you know, that the work that you're doing sort of feeds into creating those sort of national or international sort of feasibility potentials, or is that something? Are we talking about it in the wrong way? Should we really be thinking about
I think we're talking about it in the I think we're talking about it in the back to front way. I really do. The amount of time someone tells me, how much can you do? And I'm like, well, okay, well, what are you eating? What are we eating globally in 2050? What yields can you give me on miscanthus we've got today, or miscanthus that we can, you know, develop new species of? How does that handle drought? So the work that Anita's done, for example, says some of the miscanthus we've got at the moment isn't too happy with some of the drought and heat stress, you know, so under climate change. So you always get this almost like approach that says, well, just count up the land area and tell me how much you can get, right? And then you end up with this like circular argument between actually that land area, as much as in some ways it's a biophysical component, the land area that's accessible and available for bioenergy is actually very societally determined in terms of choices around food, developments on yield or otherwise. And then, you know, if you think about some of the other drivers that are not just carbon, so biodiversity, protecting existing forests, expanding, rewilding, it is, I find, a back to front question. So I sit in too many things where someone wants to tell me, just tell me what the maximum is. How much BECCS can you give me in the UK? How much BECCS can you give me globally by tomorrow? And it's like, okay, well, how are we there? What does the energy system look like? And where's that going to fit? But on the flip side, as I point out earlier, bioenergy is probably still going to play a role. It's just the question is, what extent of a role is it going to play, and how much of the bioenergy that we're going to see in a future low carbon energy system is going to be of that bioenergy gets used for BECCS. And so and yeah, so I find it back to front actually as a question, and I think that the societal constraints have some of the bigger uncertainties over and above recognizing the kind of climate change impact and the kind of carbon cycle uncertainties around some of these things as well. Phil's got a question.
Oh, you're muted, Phil.
You need to unmute yourself, Phil.
Unmute, right. It's a little bit different from what you've presented, but sort of the political acceptability, to what extent, I mean, BECCS has appeared in the science, in the IPCC, but has BECCS appeared in nationally determined contributions for net zero? I know that so many countries are committed to net zero. A lot of mention of afforestation, but how much mention is there of BECCS in NDCs?
So that is a currently advertised PhD I've got, Phil. You didn't even know that, did you? So I've currently got, as part of the Leverhulme Critical Decades, application closes tomorrow. 15th, tomorrow, is a PhD to look at that, to look at what GGR is buried in the national commitments and what are they saying about that GGR. Because I'm personally, and if there's not enough detail in there, then there's also looking at companies, because there's one too many vans driving past saying I'm net zero by 2030. There's only so many trees in the world, people, and these trees are vulnerable to pests, disease, fire. There's right, and and as Astley would say, who's in the participant list, if you take that land area to grow permanent trees, whereas you could alternately take that land area to grow bioenergy crops year on year and get more of a. So I think the political appetite, kind of my experience in the UK, don't know who's on the call, but my experience in the UK is they are skipping BECCS and going straight to DAX. Everybody loves some DAX. It's easy, it's cheap, bring it on, let's have some innovation, right? What is it? £100 million for, you're still recording this, aren't you? Whoops. 100 million, it's go on the government website, £100 million innovation fund for direct air capture and other greenhouse gas removal methods. right? I wonder, is there a preference there from a government perspective? And so BECCS in some ways being skipped a bit, and that's definitely the CCC analysis really front loads the issue of sustainable biomass supply. If you constrain it to domestic, you've got one DRAX. There's not enough domestic supply to do more than DRAX. DRAX eats a lot, right? And so if you want it domestic and not imported, you've got that scale. So I think it's niche actually. I think BECCS is niche, and I think direct air capture puts a massive energy penalty because it's basic chemistry, people, right? 0.04% of the atmosphere. You have fun with that, right? It's always going to cost you, no matter how much innovation you have, it's going to hurt in terms of your energy penalty, and you've got to meet that energy in a low carbon way, right? So you've got to take full decarbonisation of your transport sector, your heat sector. Electricity bit was easy, right? And then you've now got to power your DAC if that's the only way you're getting your GGR. So I've got 2 more questions. This is fun. Should we go to Stefano first, because we've heard from Alicia already?
Can you hear me?
I can,
okay,
yes.
I have a very specific question, not a technical one, yes, but a financial one, given my background.
Okay.
So in my bank, we are evaluating about establishing a so-called carbon finance lab. And one of the methodologies we are evaluating are BECCS. So the question is, are you evaluating your groups the link with the carbon markets or something similar? Thanks.
We haven't directly. We've got insights that would fit carbon markets and concerns about fit for purpose carbon markets. For example, that avoid, what you want to do with those carbon markets is make sure you don't incentivize deforestation or incentivize like problematically sourced biomass. So it's kind of wrapped up a little bit more in terms of like recommendations for policy rather than carbon markets precisely. So we haven't looked at finance within our project, but I think there are things in the work we've done that would be relevant or interesting when you're trying to think about how that translates to finance. We did have one participant was from a kind of financy startup kind of innovate type organization. But we haven't done that in any kind of depth. So sorry, I didn't really answer that fully. Did Alicia want to come back on her question?
Yeah, I have another question, actually. Maybe it goes beyond a bit this research, but I'm wondering whether you touched upon, well, the ideas of the stakeholders. So do they consider this as a potential alternative, or are they waiting for someone, like for the government to give the green light? Or so is it who needs to do something to actually start implementing this technology?
Okay, so with afforestation, it's about incorporation into the new ELMs would be a key element. So the new environmental land management schemes, so the beyond common agricultural policy, beyond EU land use will help with that. I mean, we have targets for afforestation. We've had them for the last 15 years and we've missed them by miles repeatedly every year, right? And so that's a kind of classic, oh yeah, we'll plant this many hectares and then we don't. And so looking at some of those kind of why are you missing that? What needs to be done there? I mean, I think there's a huge appetite, you know. I think Amazon and Sky broadband vans are all saying I'm getting to net zero, and everybody's saying they're getting to, so it feels like there's a tsunami of money headed at some form of, you know, like next generation, like it's like carbon offset Mark II, right? In terms of money's going to be plowed into this. So then the question is, you know, are you planting the right tree species in the right place to deliver genuine long-term permanent removals, or are you doing a lot of plastic trees that don't get looked after and fall over on the side of a railway embankment that they like cutting down 10 years later? You know, so I think what for me, one of the, in terms of like the innovation on the afforestation side, you've got a problem of running before you can walk happening. So there's a kind of academic, oh, this is what you should do. And what's happening in the real world is going faster and will stumble. And it will stumble and not achieve, I think, and it will stumble in terms of burning some credibility in terms of society and public acceptance. On the BECCS stuff, you don't have any BECCS unless you've got CCS. So that is very much kind of government policy and how you get the industrial clusters happening, how you get the CCS happening, how that's funded, because it's big scale infrastructure type stuff. So I think that's what's happened. That's the kind of the big pinch point there. Do you want me to deal with some of the questions in the chat, or are we done?
I think we're out of time, I'm afraid now. But what I think we do, if there's any outstanding questions, I think I see one from Olivia and Thomas, we can we can maybe do that as comments on the YouTube video. So maybe if you could answer those offline, if that's all right with you.
Yeah, I mean, I can answer Thomas's. Really quickly. CCUS is not GGR.
Okay.
Right. Use it. Yes, CCUS might be a bridging technology to make CCS happen, but CCUS in almost all cases is not GGR. Not on a carbon cycle meaningful timescale. Not compared to sticking it underground for thousands of years.
That
answer's done. It's brutal. Done.
Okay, so I'd just like to wrap up, and thanks again, Nem, for that wonderful presentation and some great food for thought with the Q&A. So thanks for doing that, and thanks everyone for coming along today. Just a reminder that next week we'll have a final webinar from Professor Duncan McLaren on mitigation deterrence. So please register and come along to that. We'll also plan to rearrange the 2 webinars that we skipped by Adrian Williams on LCA and Richard Tranter on agroforestry. And we also have 2 outstanding webinars from other projects. So we'll probably have a 4-part series, maybe sometime later in the year, to wash up the outstanding projects. So do sort of keep your eye out for those and register as they come on. But otherwise, again, thanks everyone for coming along, and thanks again, Nem, for giving that talk. Have a good rest of the day. Bye for now.